Alright, today we're going to be solving polynomial equations. We're looking here at number one. Number one says we have x to the fourth minus 14x squared plus 48 is equal to 0. This one is a nice pretty trinomial and looks like it could be set up in the form of ax squared plus bx plus c is equal to 0, our standard form for a quadratic. Well, it's got x to the fourth, it's got x squared. So that doesn't, it's almost like it, but not exactly. So what we're going to do is I'm going to come in here and say, hey, let u equal x squared. And when I do that, and I replace that back into the place of my equation, I now have u squared minus 14u plus 48 is equal to 0. And I have that because x squared squared would be the same thing as saying u squared. Now I can factor u squared minus 14u plus 48. So what can I multiply to give 48 but add to give 14? In this case, it's going to be x minus 6 and x minus 8. Because negative 6 and negative 6 give me 48, and negative 6 plus negative 8 give me a negative 14. Once I now have my quadratic equation, oh, wait a minute, these are supposed to be u's. I'm already switching things up. Pay attention to what I'm doing here. Those are supposed to be u's, not x's, u's. Okay. Now I'm going to go through and set each one of these factors equal to 0. So I'm going to say u minus 6 equals 0, u minus 8 equals 0. We're going to solve for u. One on the left, u minus 6, so opposite of a minus 6 is a plus 6 plus 6. Whatever you do to the left, you're going to do the same thing to the right. So I have u is equal to 6. My equation on the right says u minus 8 is equal to 0, so I'm going to do here plus 8. Plus 8. So I now have u is equal to 8. But remember, it's not really u, it's x squared. So I'm going to change that. So it's x squared is equal to 6. So I need to find what x equals. So I'm going to take the square root of both sides. So the square root of x squared and the square root of 6. I find x is equal to plus or minus the square root of 6. We have just found 2 solutions of our 4. Since it's x to the fourth, we should have 4 solutions. Again, with the one on the right says u is equal to 8, so I'm going to go through and change that. So it's now x squared is equal to 8 because u is x squared. I take the square root of both sides. So the square root of x squared, square root of 8. So I now have x is equal to, here you have to remember that 8 is really the same thing as 4 times 2. And I can take the square root of 4. The square root of 4, that comes out leaving 2. And my square root of 2 is inside still. And I put a plus and a minus. And I have now found all 4 of my solutions. Now all these equations are all going to be slightly different, but also slightly the same. Looking at number 2 here, we have x to the fourth minus 3x cubed minus 2x squared plus 6x is equal to 0. Our first step anytime we go to factor any type of problem is always look and see, is there a GCF, a greatest common factor? Well, my greatest common factor in this case will be x. So the first thing I'm going to do before I do anything else is take an x out of every single piece of it. So I have x comes out front. I'm now left with x cubed minus 3x squared minus 2x plus 6, and that's all equal to 0. Now that I have 2 distinct factors, I can set each factor equal to 0. So I have x equals 0, and I have x cubed minus 3x squared minus 2x plus 6 equals 0. Oh wow, look, we have already found one of our four solutions, x equals 0. Now looking at the other portion here, we do have to go through and continue factoring. I need to do this one by grouping, so I'm going to group my first two pieces together and look and see what do these first two have as a GCF. A greatest common factor of, hey, their GCF is x squared. So I can take an x squared out. I'm left then with x minus 3. I'm now going to look at my last two pieces here. I have a negative 2x plus 6. Here they have a GCF of negative 2. So I take a negative 2 out, which leaves me with x minus 3. And again, this is still all equal to 0. Notice here that my x minus 3's are the same. Since those are the same, I now have a GCF of x minus 3 for each of these terms. So I take my x minus 3 out. And in doing so, these things have been taken out. I am left with x squared minus 2. And that's all equal to 0 still. I now set each of these factors, x minus 3 is equal to 0, x squared minus 2 is equal to 0, and I solve for x in each of them. The equation on the left. Here I'm going to take and add, this is x minus 3, so I'm going to do a plus 3. The opposite of a minus 3 is a plus 3. So I now have x is equal to 3. I have two of my four solutions. My equation on the right. I have x squared minus 2 is equal to 0. So I'm going to isolate the x squared by doing a plus 2 to both sides. Got to keep my equations balanced at all times. So I now have x squared is equal to 2. So I need to take the square root. Square root of x squared, square root of 2. And I find that x is equal to plus or minus the square root of 2. And I have found the last two of my four solutions. All these first examples here, we're going to be having to go through and solve multiple times. We could have anywhere from 2 to 6, or depending on what our largest exponent is going to be. These next two examples, we're only going to have two solutions here. They are quadratic equations. The thing about these quadratic equations is we have to first put them into standard form. Our ax squared plus bx plus c equals 0. So looking at number 10, which says 22a squared minus 107a plus 28 is equal to 8a squared minus 5a. So the first thing I do is got everything to the left. To the left, to the left. We're moving. The opposite of a positive 8a squared is a minus 8a squared. And it matches up over here on the left. The opposite of a minus 5a, that's a plus 5a. And he matches up over here with this one on the left. I now have everything matched up. I go through and I do my arithmetic. 22 minus 8, that would be 14. A squared. This is going to be 102. A plus 28 is now equal to 0. It is now in our standard form. At this point, I go and survey my equation and say, do I have a GCF? Well, I actually do. I can divide everything by 2. So let's go and divide everything by 2. Since I am dividing by a constant with no variable attached, I can just basically go and divide each piece of my equation by 2, which reduces my equation to numbers that are more manageable. Here I have 7a squared minus 102a, not 102, I divided it by 2. OMG. 51a plus 14 is equal to 0. At this point here, I need to go and do some factoring. Lots of different ways we can go about doing our factoring. With this one, I'm going to use kind of a rainbow method, where I'm going to take my 7 and multiply it times my 14. So I now have a squared minus 51a plus 98 is equal to 0. I can now factor this as a minus 2, a minus 49 is equal to 0. Now since my 7 went to the right, in order to go back to the left, that means I have to divide each of these pieces by 7. Well, 2 cannot be divided by 7, so that 2, it gets moved up here in front of my a. So this factor becomes 7a minus 2. 7 does go into 49, nice and pretty, so therefore my second factor is a minus 7. And these are equal to 0. Now that I have it factored, I set each factor equal to 0. So I have 7a minus 2 is equal to 0, and a minus 7 is equal to 0 as well. My goal is still to find out what does a actually equal. Well, I am going to go through on the one on the left and add 2 to both sides. So I have 7a is equal to 2. A still not by itself, so I have to go through and divide both sides by 7. And I see that a is equal to 2/7. There's one of my solutions. My equation on the right says a minus 7. So I have to add 7 to both sides. And we see that a is equal to 7. We now have our two solutions for our quadratic equation. Here with example number 11, we're looking at 10r squared plus 5r plus 1 is equal to 4r squared. So I now need to first get it into my standard form, so I got to move that 4r squared to the left. So to the left I go, I'll do a minus 4r squared, a minus 4r squared. 10 minus 4 gives me 6, so I got 6r squared plus 5r plus 1 is now equal to 0. I'm now going to multiply 6 times 1. So 6 times 1 gives me r squared plus 5r plus 6 equals 0. I now have to figure out what can I multiply to get 6 but add to get 5. How about 2 and 3? R plus 2, R plus 3. Yes, that works. 2 times 3 is 6, and 2 plus 3 is 5. So I set each factor now equal to 0, R plus 2. But wait a minute. No, I don't set them equal to 0. Back up. We have to now divide both sides by 6. Because I went to the right times 6, so now I got to move it back to the left. So that means I got to go back this way here with my 6. So I divide each piece by 6. Well, 6 does not go into those evenly, but it will reduce. This one reduces to 1 over 3. So my 3 comes in front of the r, so I now have 3r plus 1. Now the one on the right over here, I take a 3 out of both these and reduce to 1 over 2. And that 2 goes in front of my r. The denominator always goes in front of the binomial. So I now have 2r plus 1. Now I can set them equal to 0. Whew, that was a close one. 3r plus 1 is equal to 0. 2r plus 1 is equal to 0. I now need to go through the one on the left, subtract 1 from both sides. I have 3r is equal to negative 1. I divide both sides by 3. And I find that r is equal to a negative 1/3. We have now found 50% of our solution. Yep. To find the other 50%, we're going to go through and subtract 1, subtract 1. 2r is equal to negative 1. I divide both sides by 2. Divide by 2, divide by 2. And I see that r is equal to a negative 1/2. I now have 100% of my solution. Solving polynomial equations, they're going to take lots of forms. They'll look like these equations. They'll look like these equations. And they'll also vary in many, many different ways beyond that. The main thing is stay focused, pay attention to what you're doing, and always factor, factor, factor.